Alright guys, welcome to this page of the notes, and again what we're doing is we're working on those shortcuts to prove triangle congruence. And in this case, we're looking at the HL theorem, the hypotenuse leg theorem for right triangles. Must be right triangles. So I got another one here to just kind of get us warmed up before we jump into some ones with algebra, which I'm really excited about. So here we go, one more. I tell you that angle CAB, ooh, it's a right angle given to me in the diagram. And DBA, given to me in the diagram. They're right angles. Let me go ahead and draw those triangles in different colors so that we can easily see them. I got this triangle right here, and I got this triangle right here. And again, in the diagram, I'm given those right angles. So I know they're right angle triangles. They have a 90-degree angle. Maybe a hypotenuse leg will work. Let's find out. I tell you that AD is congruent to BC. AD is congruent to BC. Interesting. Well, here we go. AD is congruent to BC. Okay, awesome. So AD congruent to BC, fantastic. I want you to prove ABC and BAD are congruent triangles. All right, well, here's what I need to know. Was I just told that the hypotenuses are congruent or the legs? Well, remember our nice little trick. The hypotenuse is always opposite the right angle. Well, there's my right angle. Yeah, okay. All right, so since my right angle is here and I'm going to the opposite side, I know that CB is the hypotenuse. So CB is a hypotenuse. And I know that AD is also a hypotenuse. So here's what I was given. This tells me hypotenuses are congruent. So I need a pair of corresponding legs. Fortunately, the diagram gives it to me. The reflexive property, side AB must be congruent to BA, right? Side AB must be congruent to side BA. That's the reflexive property. So right there, and there's my side, or my pair of corresponding legs. So once again, HL theorem, good enough. That's all we needed. I got the hypotenuses and the legs. We're good. All right, let's try a couple of these now where we'll do some algebra. Okay, here's what we've got. I want you to find the value of x that will make the following triangles congruent. Find the value of x that makes the following triangles congruent. Well, here's what I know. I have a right angle. So that means I have right triangles, right? If angle K is 90 degrees, and this is a straight line, I also know that guy has to be 90 degrees. It has to be, right? If this is 180 degrees and that angle's 90, well, these two angles have to sum to 180, so 90 plus 90, 180, right? Pretty easy stuff. You guys got that. Okay, well then here's what I know. This is a leg, and JK has to be congruent to KJ, thanks to the reflexive property. So, boom, boom. So here's what I need. In order for these two triangles to be congruent, since they're right triangles, and I already know a pair of corresponding legs are congruent, I just need to show the hypotenuses are congruent. If I can show that these two sides right here are congruent, then I know that my triangles are congruent. Which is exactly why I asked you to find the value of x that makes these triangles congruent. Well, if I need this side to be equal to this side, set them equal to each other. 2x plus 2 equal to 5x minus 19. Guys, let's do a little bit of simple algebra. Here we go. I'll subtract the 2x to this side, add the 19 to this side. I think we can do those at the same time. Now, no. Minus 2x, minus 2x. Here's what I'm left with. 2 is equal to 5x minus 2x is 3x minus 19. Yeah, Okay, add the 19 to both sides. Fantastic. All right, well, 19 plus 2, how about 21? We're almost there. To solve for x, divide both sides by 3, and we get x is equal to, well, 21 divided by 3, I believe is 7. And we have our answer. I asked find the value of x. Please read the directions very carefully. What did I ask you to do? I asked you to find the value of x, which is exactly what you've done. By plugging in a 7 for x, both of those sides are going to be congruent. Let's check it out. If I plug in a 7, 2 times 7 is 14. 14 plus 2 is 16. What about the other one? 5 times 7. 5 times 7 minus 19, again, would be 16. So again, by doing x equal to 7, I wind up those two sides being congruent, which is exactly what I needed. All right, I got another one for you here. Once again, I show you in the diagram. Right triangles. I have two right triangles. There's my right angles right there. Side AB and side BA. The question is, AB is congruent to BA. That's the reflexive property. That's the reflexive property, but is that a leg or is that the hypotenuse? Leg or hypotenuse? Well, again, hypotenuse is opposite the right angle. Oh, definite. Yeah, for sure. So I know the hypotenuses are the same. I need to show that a pair of corresponding legs are the same. Well, what do I have? I have a leg right there, leg BC, and leg BD. So I need to show that leg BC is congruent to leg BD. I need to show that those guys are congruent. We'll plug in what we know. BC. BC is x plus 8. That has to be equal to leg BD. BD, 3x minus 14. Fantastic. Guys, we got ourselves another algebra problem we can solve pretty quickly. Subtract x to the other side. 3x minus x, 2x. Add 14 to the other side. What do I get? 8 plus 14 should be 22. Great. To solve for x, divide both sides by 2. 22 divided by 2. How about x equals 11? Now, what did I ask you to do? I asked you to find the value of x, which is exactly what you did. If you were to go ahead and plug 11 in there, I get 19 and 19, right? Which is exactly what I want. I need those two legs to be the same. Awesome job. I got one more for you here. Let's see how this one goes. All right, first let's take a look at what we know. Let's see here. Okay, look, so I got right angles in my diagram, so I know that they're right triangles. That means all I have to do is show that the hypotenuse and a corresponding pair of legs. Well, right there, right? MP, this guy. I know thanks to the reflexive property, MP has to be congruent to PM. The question is that a leg or a hypotenuse? Well, remember the hypotenuse is opposite the right angle. There's my right angle, opposite, hypotenuse right here, right angle. Okay, so the algebraic expressions, the 7x minus 5 and the 4x plus 1, those are my hypotenuse. So that means that these are a pair of legs. Okay, great. I need the hypotenuses to be equal. I need them to be equal in order for the hypotenuse leg to work. So I need MQ to be congruent to NP. Well, let's do that. MQ, 7x minus 5. I need that to be equal to NP, the hypotenuses. I need these hypotenuses. Oops, sorry, I apologize. I need these hypotenuses to be the same. I need them to be congruent for HL to work. So we set them equal to each other. All right, let's do a little bit of algebra here. Subtract the 4x to the other side. This isn't bad. 7x minus 4x You guessed it, 3x. Let's go ahead and add the 5 to the other side. That's not bad either. What is 25 plus 5? Sure, it's 30. Divide both sides by 3. 30 divided by 3, 10. What did I ask you to do? I asked you to find the value of x, right? Asked you to find x. There it is. If I were to plug it in, I don't know, what would you get? 7 times 10 is 70. 70 minus 5, I get what, 65? Do it again. 4 times 10. 4 times 10 would be 40. 40 plus 25, 50, 65. Yep, 65. But that shouldn't be a surprise, right? I wanted these two sides to be equal, so I set them equal to each other. And I found the value of x that'll make those two sides equal. Now I have hypotenuse leg. Guys, thank you so much for joining me for this set of videos. I had a great time taking a look at the hypotenuse leg theorem for right triangles. Hope you enjoyed yourselves. I'll see you next time.